Welcome to the Hazard Class Podcast. This is the podcast where I get to ask my stupid questions to some of the smartest people in the world of emergency response. My guest today has been working in and around the fire service for the better part of the last 30 years. He's a retired captain from Oakland Fire. He's the owner of LeGear Engineering Fire Department Consulting. He's working most recently with Fog Nozzles. We'll talk about that today. He is one of the modern godfathers of engine company functions. My guest today, Mr. Dennis LeGear. Dennis, thanks for joining me today.
Thanks for having me. I appreciate it.
Of course, yeah. So as is customary on this podcast, we try to encourage people to ask the dumb questions because sometimes we feel too self-conscious to ask the questions that might need to happen in order for us to learn. So I open the podcast up by spinning the wheel of stupid questions. We open it with hopefully the stupidest question you'll have to answer from me today. It's not a guarantee, but it's certainly possible. All right, so I literally do have a wheel. I'm not faking.
All right, sweet.
We had to do some arts and crafts at my house, but so here we go. We'll see where we start here. Would you rather always be kind of itchy or every time you have to go to the bathroom, it'd be an emergency?
You know, I believe Mother Nature, Father Nature, or God tried to make those feelings pleasant. Your normal bowel functions are pleasant, so I'll take itchy.
Itchy, okay. There we go. I was justifying this with my wife earlier as we were discussing, and I was saying, I think I could probably get used to being itchy, but I don't know if I would want to deal with the consequences that was the other.
Anybody who's had that kind of emergency, which we all have had, knows the consequences can be severe.
For sure. All right. So thanks for indulging me in my stupid questioning. We'll get on to what you're actually here to talk about. So, Dennis, tell me about your journey to where you are now, and more specifically, what inspires a man to be obsessive about the efficiency of water application?
I think the most iconic thing in the fire service is fire stream development, and probably the most iconic thing on a fire engine is the nozzle itself. And I think that's why it's so hotly debated, nozzle designs, nozzle types, stream pressures, reach, and all that stuff, because the one thing you can say for sure is that more lives and property has been preserved by the application of water in a gold standard way than any other single action or regime that the fire service is currently engaged with. And I don't see that changing anytime soon.
So being this your passion, I don't know if I want to say a passion, but I think it's passion at this point in your career. What do you say to members of the fire service that say, the hose always comes off, the fire always goes out, I don't care about the technique? Unfortunately, teaching, I get that pushback all too often, and it's frustrating. What do you say to that when someone brings that up?
Well, it just depends whether you have those fires or not. Someone can go an entire career and have basically bread and butter room and contents fires that could be put out at a flow rate as low as 40 gallons a minute. And those obviously produce laden gases that you need to search and make sure there's victims out of the building, right? Those aren't the types of fires where gold standard fire stream development and application methodology is paramount to success. So I would say in the UL studies, we had in the fire attack study, which I was a technical panel member on it, basically Aaron Fields, myself, and Ray McCormick were the only one arguing to study flow and move. The rest of the technical panel was like, I've never had to do it. Why should we even include it in the experiment? So we have to basically say, hey, some of the largest organizations in the American Fire Service, that is the normal way we do fire, and we feel that there's benefit to it. Sean, I'll remember his last name. Oh, Sean Gray from Cobb County. He's a board member at the UL. He was present, and he was like, well, I'm not so sure flow and move is necessary. And then in the coordinated fire attack, he had to flow and move down into a simulated basement fire. And he's like, man, I wouldn't be able to shut off the nozzles. We would have burned up. So not only did he have to flow and move down to safely exit, he had to leave the nozzle on. And that was with him knowing the exact fire conditions. So I would say that, complacency, really, that's it.
Yeah, I think that is something that I've, hammered home in teaching, is that, we don't train for our best day. We don't train for the bread and butter. We train for the worst day, and then everything else gets easier because of it. And so I think that kind of is that same kind of concept, is that if we train to the lowest common denominator in our fires, we're going to get beat sometimes. But if we always train to the highest form of training, then, we're going to look like studs, even on the bread and butter, right?
Yeah, I mean, I think there's some rules. Like if you have an engine company emergency, like a loss of water or a reduction in water, like there should be people on the fire ground thinking no additional ventilation shall take place until we correct the flow emergency. Or if you're caught in a rapid fire development, what happens when a room you're in goes rapidly to flashover? Where do you aim the nozzle? The answer is you don't aim the nozzle. You just put it into the overhead and open it and pray. Why is the flow rate 150 gallons a minute and not 90 gallons a minute? It's basically bounded on nozzle reaction, which is about 60. It's about what most human beings can deal with. What's the highest flow rate we can get at 60 pounds nozzle reaction with a reasonable velocity? 50 psi is 85 feet per second. That's 60 miles an hour. I know I'm throwing a lot of numbers out there, but these are the things that I think about. And I'm like, I want to flow 150, 160 gallons a minute, because when I do the math, a room of around 500 square feet with a stream directly overhead should rapidly go to less than 400 degrees at 3 feet off the floor. Why is that important? That's your face piece. So if you can rapidly lower that temperature at 3 feet off the floor to 400 degrees and below, it means it's a survivable event. It's not survivable at 50 gallons a minute. It's not survivable at 100 gallons a minute. So we use that residential flow that's kind of benchmarked in NSPA 1710 to have tactical redundancy and safety, not necessarily always to put the fire out.
Yeah. So tell me this, what's the history of this modern attack package that we're using now, right? How obviously we have departments that are doing exactly right. We have departments that are maybe a little bit off. How did we get here, and how do we have options, and how are so many people using the non-optimal version? What's the history of getting there?
I think we've been blessed by our maker or father nature or mother nature with a extinguishment material that far outperforms skill set. Water is so good at going from a solid state to a gaseous state and absorbing so much energy that even poorly done or shitty water application usually yields good results. So water really makes us the stars. So it's, in other words, it's kind of usually like, room and contents fires, even several rooms of fire. If you're doing a pretty good job, it's kind of like stealing candy from a baby. It's the 5% or 6% where we get in trouble. So in other words, you can go with a non-ideal package, a long part of your career. And you can be like, let's say you have, I don't know, over your career, 90 good nozzle fires, and you were pushed out of 20% of them. So 18, you might be like, hey, I'm batting 80%. If you had a better hose and nozzle package and a little better methodology and application regime and practice regime, you might have actually batted 95% and 5% failure, right? So it's basically, you don't know what you don't know. I will tell you this. I have consulted for many large organizations, one of them being Tualatin Valley Fire in Oregon. They were the agency that bought over $1 million worth of hose that I got True ID made as a custom hose for them. We moved from 100 GPM, 125 GPM at 100 PSI flow to a 160 at 50 PSI flow. Over about a 5-year period, they had their second alarms drop by 50% with the same fire duty and a rapid reduction in property loss. Does it mean the prior 20 years, those firefighters were any less dedicated, passionate, or anything? No, they were just using a less effective attack package. Go deer hunting. Have one with a scope, have the same rifle with and without a scope, right? You're going to be more successful at putting food on the table with a scope. I'll give you another example. Bill Baker, super nice guy, training chief of the Toronto Fire Service, one of the largest fire departments in North America. I was just up there visiting early the first week of August, and he's like, hey, next time you're on a podcast, Dennis, he's like, definitely mention Toronto Fire. He's like, we've moved to this low pressure attack package. Brett Brooks is here teaching in the Bay Area, the high-rise firefighting guy. He's here at Redwood City, Toronto firefighter member. He's done big things in a high-rise. They've moved to this 265 at 50. They've also moved the 160 at 50 off the rigs. Now, guys don't like the kinks. You know, that's kind of what the Hen Turbo is about. You know, there's things we can massage, hose spec and other things, how heavy the nozzle is. But universally, you know, the guys that are really into the job there are like, yeah, the fires do go out faster. You know, like we're taking a bazooka, you know, into where we used to, you know, it's putting a fire out, even a major fire, if you're doing it right, it should be like an assassination. We're not there to make friends. Like we're there to save lives and property. If you feel like every other fire you're taking a beating and these are room and contents fires, it's probably what you're doing, not the fire. Those should be easy fires.
Yeah. Yeah, you bring up a lot of really good points. So if we can clearly say through science, so the research you've been involved with, UL and others, that, you know, low pressure, high gallonage, smoothbore nozzles are superior, what is the resistance to a large portion of the American population still using automatic fog nozzles?
Yeah, you know, like, so automatic fog nozzles, you know, you can't get something for nothing. There are some pros around automatic fog nozzles. First off, they're usually never less than a 75 PSI nozzle pressure. So they have about 50% more mechanical back pressure than a 50 PSI nozzle. So it helps the hose stay stiff. The other thing about an automatic nozzle is that a lot of people, you know, they bake at 350, pump at 150. So they're pumping at 150 and they're usually 100 PSI. So if they're doing friction loss of like, let's say 30 per 100 or 15 per length, and they're pumping at 150 to 160, the nozzleman, a fog nozzle, when you bail it down, you don't lose stream quality. So, you know, they might have an effective flow rate of 80 to 100 gallons a minute, even though the fire chief has checked the box. Hey, I got a 150 at 75 automatic nozzle. I'm doing 30 PSI per 100 in my 100 feet of hose, or 15 per length. I'm telling my guys to pump at 150 to 160. With the bail fully open, I should be, boom, I'm an NFPA 1710 compliant. I'm flashover safe. I have a tactical redundancy. But in real life, they're bailing down. Now, a smoothbore nozzle is an officer. The reason I liked having a smoothbore nozzle, which was a choice for us in Oakland when we pulled off the stretch bed in the back, it was always a 7/8. Me as the backup member on the line with my nozzle firefighter out in front of me, in low visibility, I could instantly tell whether the nozzle was fully open or fully closed, because if he started coming or she started coming off her feet and they start bailing down, I can hear that chatter and that thing, and then I can hit them in the head very politely and yell them to open the nozzle back all the way open, right? So, you know, so the automatic nozzle creates some forgiveness around the wrong hose spec, poor kink discipline on the fire ground. These are all teething problems, you know, like TVF&R in Toronto. One of the big things when I was up in Toronto, I visited a firehouse and guys were talking about like, yeah, we got low pressure hose in this, but we're still dealing with kinks. And, you know, that's one of the things, you know, not everyone's going to get to see this, but, you know, that's the turbo from Hen. I've created a device that can go into the female end of the shutoff, and it creates a 25 pounds extra back pressure but it only allows 160 at 50 through. So you get a 7/8 inch stream with that low reaction force, but you get behavior in the hose like a 75 PSI back pressure nozzle. So it's way better than a 150 at 75 fog nozzle because that's 70 pounds nozzle reaction. I can give you 60 pounds nozzle reaction and 75-pound back pressure. And we're doing this with 2-inch hose now. So that's another thing. Some people go like, when is technology going to stop? Right? It's a constant refinement. You know, like imagine if you've been in the fire service a long time, think about thermal imagers that were, you know, being hot and generally just pushed on the fire service in the early 2000s. They were total garbage. Yeah. Andy Sarnes is now helping at Hen Nozzles. He really likes the way the pattern looks in the thermal imaging. He sees the return on investment. You know, it was very nice to have him come over and become an advisor for the company. You know, he very much believes in the pattern. He can see it in the thermal results, but he'll be the first to tell you that, you know, there's difference between thermal cameras. It's not my cup of tea. And he'll say the first cameras were junk, but that didn't mean there wasn't a constant evolution. So, you know, look at Master Stream nozzles. That's going to be the next thing that gets disrupted. Go ahead.
Yeah. So the department I work for is in the process of nozzle testing, and we were fortunate enough to get Hen out to run through the paces. And like, I'll say this, we haven't talked about this yet, but I will tell you, the build quality is crazy. You take it out of the bag that we got it in, and it was like, oh my goodness, this is a different thing. Like from the finish to the fit, everything just feels. It's like when you open the door of a BMW and you're like, wow, this is really nice. It felt that it was palpable when you touch the object, that it's just a different level of quality. I was really impressed with that. Like, we had all the major manufacturers there, and like Hen stood like head and shoulders above when it came to just like palpable build quality, which I was really, really impressed with.
There's just some things that you're not going to realize that went into the thought. Like, you know, a lot of people like single stack Minuteman loads. A shutoff's a shutoff in many ways, but I was very careful when I was designing it. I do a lot of rig consulting. You know, I help people spend not tens of thousands of dollars a year, but like, you know, like I advised Calgary on their apparatus purchase. They're buying $34 million worth of apparatus. You got to get it right. You know, like you don't want to make mistakes. You'll never get everything 100% right, but we made sure that the bail was thin enough to go into a single stack or a PUC or, you know, puck ultimate configuration pumper or some of those felays. Not that I like any of those things, but the shutoff had to be designed in a way that had a short enough cross-sectional ratio that it didn't have to have a really wide opening to come out. Because, you know, some guys will say, I want to learn Minuteman, but I want to be able to pull it from both sides. And the shutoff itself prevents you from doing that. So there's, you know, Ray McCormick put a ton of thought into the shutoff. And that build quality, I would say, is related to the guys that are, they're not fire engineers. They're basically mechanical engineers that came out of the solar industry, and that they have no preconceived notions. So like, I've never been involved with a fire apparatus manufacturer or manufacturer of loose equipment in the fire service where I say, hey, can we do this? And not have them say, oh, that'll cost too much money, or shit, we already have that. These guys are just like, oh yeah, sure, let's try it out. And they have a really nice set of 3D printers. Like, you can't do this kind of design work where you're just like casting or making stuff out of metal as a prototype. Every one of these things has been made out of plastic first. It's ridiculous. You know, like it's just really interesting.
Interesting. So one of the main things of this that we were like just blown away with, because we had multiple different types of hoses. We had multiple different types of nozzles, as I mentioned, but the turbo is something all of its own. It is like, it's like a magical piece of fire department equipment. It's everyone that utilized it was like blown away by it. So talk to me about that design process. Obviously, like, it's pretty obvious what you were trying to do, get a low pressure nozzle functioning with a stiffer hose. But what were some of like the things you had to overcome to make that happen? Or was it as simple as just like snap and make it happen? I can't imagine that's the case.
No, we ran it through. I told them about it last year. It's always been my idea. I've just never gotten around to it. And, I'm one of those idea guys that fails on execution. And, all of a sudden I have access to these engineers that are willing to listen to me. And they're like, well, why would you want to do that? There's a lot of like surface area to balance ratios that I won't get into. One of the things that's extremely interesting is that at 160 gallons a minute through a true 1.75-inch hose, you get a fluid velocity of about 21 feet per second. The faster a fluid moves through a pipe, the lower the sidewall pressure. So we know this in the fire service is, hey, when you're 5 inches getting stopped, you're running away from supply. So having water aggressively traveling through a hose and knocking out kinks for you, which we want somewhere between a minimum of 20 to a high of 23. The reason I always stopped at a high at 23 is that as water travels through the hose quicker, it becomes like the Tasmanian devil, and the hose gets soft itself. And what a lot of people don't understand is in the last 3 feet of hose, which is the most critical for the nozzleman, there's essentially no residual pressure left. There's only nozzle pressure. If you do 30 psi per 100 feet, that's only 0.3 pounds of residual pressure per foot. So there's only about 1 psi of residual pressure at the end. So nozzle pressure is it, man. So I thought, what if we disassociate nozzle pressure with back pressure? Let's say I design a nozzle, which, by the way, this is going to happen. You're going to be able to check a box and get a nozzle that has a X discharge pressure and X back pressure. So like I'm working with fire departments in Southeast Asia, in Iceland, because we can't guarantee what kind of hose they have. But I know for a fact that the research shows that a GPM focused low reaction fire stream that has a stream velocity somewhere between 77 and 95 feet per second in that 160 range is a murderer of fires. And then if you do the pattern, which we can go into, if you think the turbo is magical, the bladed pattern fire dynamically is just insane. Like it is such a watershed moment. I'm just proud to be involved. I can't speak to that enough that at the end of my career here, I just turned 50. I would have had 31 years in fire service. I would have definitely been maxed out on my pension. This has reinvigorated my interest in the fire service, working with this, because I've been telling this kind of stuff to nozzle manufacturers that shall remain nameless, but let's say all three big ones. Like it's not just one where they go like, nobody would want that. It's hard enough to get key fire hose to make a smaller, stiffer hose, because everyone that I approached in 2016, 2015 for Tualatin Valley, everyone was like, why would they want a hose that lays less flat? They're going to complain. And I'm like, you don't understand. Like the whole fire service is going to 50 PSI nozzle pressure. Like you got to get ahead of this. So, Key had the chops to listen. But by the way, things happen for a reason. Now we have something like Sniper or a Mercedes Kraken, or we have this other premium hose that really Key led the charge, but market forces made competitive products, and people go like, well, now you have a 75-pound back pressure. Well, that last 10 years of your life was a waste. No, it wasn't. 75-pound back pressure with a 60-pound nozzle reaction on a product like Sniper, it's like Formula One level precision. It is so freaking ridiculous how unkinkable the line is. So all these naysayers that, hey, you're in it for the money. Dude, I'm not calling you from the British Virgin Islands. I'm not, look at my house back here. This is the same house I've lived in since I started in Oakland, right? I bought this house in 2001. About 5 years into my career at Oakland, I just love this stuff. And I know that the better we do water, the faster a search. You know what the best search is? You know what the best search is?
What is that?
One protected by a gold standard fire stream. Because then they can be as aggressive as all get out. I can use the F word there. They can be as aggressive as bleep. because they know they're being protected. And that's
Absolutely.
our job. That's our job as engine men.
So you touched on it briefly, but I want to hit on it specifically. What's the limitations of the turbo? Is it as much pressure could you continue to shrink that opening and make 100 psi line with a 50 psi discharge, or can you keep going up and up and up?
You could. You'd have to make it longer, and there's some issues with the laminar stream. But I'll tell you why you wouldn't want to do it. Okay, this is the story of Goldilocks. Like this porridge is too hot. This porridge is too cold. This porridge is just right. One of the problems with 100 psi nozzles, unrelated to reaction force, but in the hose, kinks are harder to occur. They're about twice as less likely to occur than a 50 psi back pressure. But when a kink occurs, it's a tight kink, and it includes a lot of water. You'll have like 30% fall off of water. If you have like a 150 gallon a minute flow rate and it's 100 psi back pressure nozzle, a 150 to 100, which would be 75 pounds nozzle reaction, which is a lot, but guys could hit and move with it. But if you get a kink in that line, and you open the nozzle, it's going to be such a tight kink, it's going to occlude a lot of water, and you're going to go from 150 to 100. A 50 psi back pressure nozzle with the same 90-degree kink, you only lose about 10 gallons a minute. So there's kind of a fine line between too much back pressure and too little back pressure. And not a lot of people nowadays have the glory days of the 100 psi unkinkable. The 95 GPM 100 psi nozzle line was 50 pounds nozzle reaction. You could just never kink that line. But one of the issues with that line, especially an 1 3/4 with 100 psi back pressure, is it becomes almost too stiff. Like you're trying to work it around a corner and you're like, hey, open the nozzle, jack off. Like I can't get the hose around the corner. So I've had people go like, hey man, make a 50 psi back pressure turbo. And I've told the owners of the company, don't do that. It's our responsibility to roll out products that aren't gimmicky and have a huge return on investment. And frankly, I did everything to try to make the bladed pattern fail in the structural fire world. I tried to push air with it. We advanced against Novant. If anything was unsafe, you think Ray, Eric, or me would be involved. And by the way, Eric Gita, he is nationally known, but he's just not, he's not a household name in the engine world. That guy is a 30-year senior engine captain from Sacramento, one of the busiest engine houses. I passed on Hen. Hen picked him up after I was like, hey, I'm not interested. 7/8, ride or die, I'm not interested. And Eric called me back. Eric said, hey, dude, I think you're missing something. Come back. If I didn't have that kind of respect for Eric Gita as somebody who's really, I did half a career in a busy place because I got injured. He did a full career in a busy place. He has way more fires under his belt. And I was like, I wonder why Eric likes it. So, first impressions are tough. Like I threw the thing under the bus. I believed it in the wildland, but I didn't really believe it in structural fire.
Yeah, so you've touched on the blade. So let's break down the blade, right? Everyone's used to a normal combination nozzle. You open it up, you have that, conical or cone-shaped pattern. The blade now is going to turn that pattern from a true smooth bore to a flat, arc. How would you describe it? Break that down for someone that's not familiar with the product.
Yeah, the way to think of it is that when it's in the tight mode, it's basically analogous to a 7/8. So a 160 at 50 Hen in the tight mode, it is a 7/8 inch stream. When I sent they asked everybody in the fire attack study at the UL panel to send in a gold standard flowing approach. And Jay Kamel and I happen to be teaching in Vegas, and we sent students through an acquired building, a casino, and different things. And I was filming, and I used that footage as my instructor's footage for the research scientists at the UL. And they came back and they said, "Hey, Dennis, we don't understand the patterns you're working. There's no discernible pattern." And I'm like, I don't know. No one's told me I have a discernible pattern. I was just taught to beat the shit out of every surface. Right. Yeah. The more surfaces I could collect the quicker. So a lot of I like to squash dough. I like slamming the smoothbore nozzle side to side to break the pattern up, catch the couch, catch all the cabinets. I mean, anyone who's seen me work a nozzle in my prime, I was like Animal on the drum set on the Muppets. Like, I really didn't, if once the shit was lights out and I was moving forward, I wanted downstream gas contraction. I wanted the door open behind me. I wanted people breaking windows in front of me, and I wanted to be reversing the flow crash, shrinking those gases. Now, did I know all the verbiage of what I'm just telling you? Absolutely not. Did some guy named Tommy Stinson and Lyle Elvin in Oakland be like, have the nozzle open early and often, use a straight stream, crash it around? Yeah, they had the ghetto firefighter experience. Like they're like, this is what works. So I was the benefactor of that, socioeconomic condition that creates fires in our urban cores. And I had decades of people with that experience that taught me. So that being said, the bladed pattern is essentially, let's say it's about 8 wide, 6 inches thick, 15 feet away from you. So you still get 40 gallons per minute per square foot, or about 2/3 of a gallon per second. So if you think about it, if you take 80 ounces of water and you pour it in 1 square foot, have you cooled that square foot enough? Absolutely. So what I used to have to be really talented at to do with a smoothbore nozzle, now it's just like swipe. I get all the kitchen cabinets, the center's wet. So it's making gold standard suppression much easier for a larger group of the fire service. And by the way, you can't replicate, even if you're if you're the Jay Bonifields of the world from Everett, he's actually used the bladed pattern in a structure fire. And he was just like, you can't duplicate this. He's like, it doesn't mean the fires aren't going out with the 7/8, which I totally agree. Hey, you just bought some Elkhart XD nozzles and 7/8, or you just, Houston's thinking about buying all new nozzles, and the committee's already made the choice, and they're doing 15, 16s. I'm all pro GPM focus, low reaction force, good hose and nozzle package. The turbo to me is a no-brainer, but the blade really is a no-brainer as well. And I think essentially the proof's in the pudding. I mean, we've vetted it. We're getting some third-party research done. I just think it's just a matter of time before every nozzle manufacturer is trying to produce something similar. But remember the build quality. I would hate the guys that got there first to not end up having a large part of the market. They really deserve some credit.
And I hope that the listeners will get a chance to get one in their hands, because it really spoke for itself. It was truly like, it's rare to pick up a tool and be like, holy hell. And that's how I felt when I picked up the hen nozzle for the first time. And you didn't even know this, so I don't want this to come off like it's a big commercial. You didn't even know that I've even seen a hen nozzle before.
It sounds a little plain, I have to say.
It does. I promise you that me and Dennis just talked for the first time about 45 minutes ago, and he had no idea that I've even seen a hen nozzle, but it was truly remarkable. So I'll let you get out of here, but tell the people where they can find you, where they can find more information about hen, and get in touch with you for training or anything else.
Yeah, so my last name spelled LeGear, LEGEAR. If you just put LeGear and fire into any internet browser, it'll come directly to me. I have a website that I don't know how it works. Someone made it for me, but my contact information's up there. To be honest, email's the best way to get a hold of me. I'm sure that Jake here can put up my email address at the end of the podcast on YouTube. I have more work than I can do with, but I try to answer all the emails. I have a huge network. If I can't do it, somebody in my network that I really love and respect, the Aaron Fields, the Gary Lanes of the world, David Quicks there on the East Coast. There is talent is not lorded on. It's not. It's There's lots of talent out there. There's lots of people doing great engine work, great engine classes. Steve Robinson. Todd Edwards. So like there is absolutely people that are on. And the reason we're on the same page is why. Why is our job better than a police officer's job, Jake?
Because the public loves us. That's
Well,
my opinion.
That's a good way. That's one good way. Police officers deal with humans, and humans are stupid and angry, right? And they act emotionally. The best part of our job is a physics problem, right? It doesn't matter whether you're doing a rescue call or you're doing a fire suppression, right? There is usually an answer that is most correct or will yield good results. So we get to pre-plan and train. Cops, man, they're dealing. Imagine if a fire ran down the street and burned you up in your firehouse, right? It came in, snuck in, and attacked you in your bed. That's what poor police officers have to deal with. So, like, we should keep making progress. And, it's going to piss some people off, and I get it. And by the way, the best fire is the one that's extinguished. So make use of the tools you have, learn how to use them. If you only have a fog nozzle, let's say you have some fog nozzle like a 185 at 75. Oh, you can underpump it. You can turn it into a 150 at 50. You can make it. You can do a lot of stuff. So, the most important person on the fire ground is a well-trained, knowledgeable firefighter and team. Like they will make bad equipment into amazing things.
That's absolutely true. Well, thank you for talking to me today. Thank you for your dedication to the fire service. Thank you for pushing us forward to hopefully a better generation of firefighters in the future.
Thank you. I really enjoyed myself.